Hello friends, in this lecture I would like to explain another topic based on the shape factor for the I section. So already in the last lecture also I explained shape factor for the symmetrical I section, but here this one will be unsymmetrical I section. So what is the difference? I will explain here. So the flange will be around 100 mm. I will take the properties here. So this web will be, so the thickness of the flange will be around 20 mm, and again purely this web part will be 20 mm, and the height of this web will be around 150 mm. So I am taking some unsymmetrical way related to the thickness and web, and again here this will be around 150 mm. So in the last example I take around 200 by some 250 overall height, but here it will be different. For the section 1 it will be 100 by 20, and section 2 150 by 20, and section 3 20 by 150. So like that there will be unsymmetrical manner. So for this also you have to find shape factor in the same way, but there will be small difference. So shape factor will be equal to plastic modulus of the section to that of the elastic modulus of the section. Again we know the shape factor, so the plastic modulus of the section will be taken as a by 2 into y1 bar plus y2 bar, and again elastic modulus will be equal to I by y max. Again in the ZP area I will take down this A1. So what is this area? A will be equal to first section 100 into 20, second section 20 into 150, third section 20 into 150 again. So if you simplify, how much you will get? So the area of this I section will be overall will be equal to 8000 in mm square, 8000 in mm square. And again we want to find y1 bar and y2 bar. So for finding y1 bar and y2 bar, exactly we divided half of the section in the previous symmetrical I section, but here it is difficult to find the equal area axis. For that what we are doing means, I will take some half of the section by assuming some distance. See here how I will take means, I will take this half section exactly. Okay, so it is at a distance of h. Okay, it is at a distance of h, means in the overall I section I don't know where is the equal area axis lies. So this is the equal area axis part, sorry, this is the equal area axis or neutral axis part or equal area axis. So I am assuming at some h in the overall height, I am assuming somewhere at distance h it will be lies, equal area axis will be lies. So for that I am considering only half part in the upper section. So we know the condition overall area. So overall area of this A section will be equal to this A1 by 2, means half of the upper section plus A2, means what I am taking means this overall area 8000 will be equal to this format 4000 plus 4000 format, but I don't know how 4000 will be coming for the upper section. For that what I am taking means area by 2, means exactly I am dividing for the 4000 purpose, like this I am dividing, equal to A1 part to A2 part, means in this A part A1 part to A2 part. So like this I am solving. 4000 will be equal to A1 will be equal to 100 into 20 plus A2, we don't know the height, therefore taking 20 into h. So if you simplify you will get h value directly here. How much your h will be? 100 mm. Okay, so this will be 100 mm, means based on this we know that in the overall I section the equal area will be lies at a distance of 100 from the equal from this web part. In the overall 150 web, it is at a distance of 100. So bottom will be 50. So if you simplify differently, individually, the upper part equal area axis 100 by 20, lower part 50 by 20, and again 20 by 150. So like this, the equal area axis will be finding for unsymmetrical I section. In the same way, you can find for T sections also, upper part and lower part differently, based on this equal area axis method. So here we know that this H value will be around 100 mm. And again, so next step is finding y1 bar in the top portion. So for finding y1 bar, we are taking your CG lies somewhere at a distance from the equal area axis. So for that, what we are doing, again we are resolving to the exactly equal area axis, a1 y1 plus a2 y2 by a1 plus a2. So what is this a1? I am taking first section 100 into 20. And what about this y1? y1 is the distance taken exactly from the center exactly from this center to the bottom up to the equal area axis. For that, 100 plus 20 by 2. So y1 equal to 100 plus 20 by 2. You will get 110 value directly. Plus a2 is only this part, bottom part, 100 into 20. 100 into 20. Again, this y2 is the distance exactly this a2 by 2, means y2 by 2 means 100 by 2. So this y2 is the distance of the web part to the equal area axis, which is exactly half of the distance. Okay, by a1 plus a2. So this is same like previous one only, plus this 100 by 20. So if you simplify, how much your y1 bar will be obtained? Your y1 bar will be around 80 mm. Means your CG lies at a distance of 80. Your CG lies at a distance of 80 mm from the equal area axis. But in the previous symmetrical I section, your y2 also same from bottom section and top section. But in this unsymmetrical I section, it will be different. For that, again you have to find taking this bottom section differently. So I will cut this section exactly, and again I will find for this one also in the same manner. Okay, see here, I am assuming somewhere your CG lies at a distance of y2 bar. Okay, so for that also the same formula, your y2 bar will be equal to a1 y1 plus a2 y2 by a1 plus a2. So take down first this section only, this remaining section 1 and 2 like this, or else you can take down the second section and third section. First I will come with second section. First area, so this part will be 20 and height will be 50. 20 into 50. What is the distance taken exactly this distance by 2? 50 by 2 means 25, plus bottom one 20 into 150, area 20 into 150. What is y2? Distance taken exactly from the center to the equal area axis. So for that one, 50 plus 20 by 2, which is 60. 50 plus 20 by 2, which is 60, by a1 plus a2, that is 50 by 20, and again this 150 by 20. So if you simplify directly, you will get your y2 bar will be equal to 51.25 mm. So we know each and everything for finding plastic modulus. So area will be equal to how much? It will be 8000 mm square by 2 into y1 bar will be 80 mm. Now it will be simplified. Y2 will be equal to 51.25. So overall your plastic modulus of the section will be equal to 525 into 10 to the power of 3 into 10 cube mm cube. And again we know one more thing. What is ZD? That will be equal to I by Y max. So here If it will be symmetrical section means we can take exactly d by 2. But here unsymmetrical I section. So for finding y max also we can resolving the force taken from top to or bottom. So for that I will explain this one separately. So I will take again here ZD will be equal to I by y max. First find the y max for this symmetrical I section. I will take the same section again. So here itself I will take, no problem. So for finding this y max, taking moment areas above top means resolving above top. For that you will get one formula a1 y1 a2 y2 plus a3 y3 by a1 a2 a3. So please remember this formula directly and take down this first section area 100 into 20 means we are resolving the moments to the top. Remember that one also. So I am resolving distance means I am taking each and every time to the top only for finding y max. So what is y1? Y1 means this first part distance by 2 to the top 20 by 2 means this one up to here, this is y1 20 by 2 which is 10 plus about a2. Next one is a2 y2. A2 is 20 into this web part. How much it will be? 150. 20 into 150 into what is y2? Y2 means this web part will be taken to the top means this web part distance by 2 to the top. This is 150. 150 by 2 means 75 to the top. So this is 75 somewhere at a distance exactly center to the top 75 plus this 20 which is 95. Okay, plus a3 is this third section 20 by 150 first area, write down area. So distance is only somewhat confusing here, but don't confuse here. Each and every section distance by 2 to the top. See here I am talking about the third one. This third one distance exactly from the center to the top. You only calculate how much you will get. So I am talking like this. Exactly this one means this 20, this 150, this 20 by 2 which is 10. 150 plus 160 170 180. So overall you will get 180 directly. Like that each and every section half to the top. Here half to the top, half to the top, half to the top. Like that we can divide individually a1 y1 a2 y2 a2 a3 y3 and then again a1 will be equal to 100 by 20, a2 will be equal to 20 by 150 which is second section, first section. Third section will be again this is plus 1 20 into 150. So simplify this one. How much you will get? You will get y max will be equal to 105.6 mm. So from the top your y max will be at a distance of 105.6. So I will take here it is 105.6, that is your y max. Okay, like this somewhere. And what about bottom? From the overall depth which is in the 250, if you remove 105.6, how much you will get? The remaining part will be, sorry, so the overall height will be 150 plus 20 plus 20 which is 190. 190. Okay, so 190 minus 105.6, the remaining part will be 84.4 mm. Okay, so the maximum distance will be 105.6 and the bottom remaining part will be 84.4 mm. Okay, then find out the moment of inertia. So generally moment of inertia for the I section will be bd by 12 plus a into y square, but for symmetrical section your h will be equal to 0, but here you will get h value also. I will show you that part here. So I am taking all this part for my calculations. Okay, so next part is resolving I section, which is I value, moment of inertia. So what is generally Ixx will be equal to Igg plus a into y square. So how this will be obtained? This will be obtained based on the parallel axis theorem. We know that one well. So here again there will be three parts, first, second and three sections. I will resolve based on this maximum neutral axis and next one. So what is IgG? BDQ by 12 plus A into y square. So first section. So don't be confused here. 100 into 20 cube by 12. 100 into 20 cube by 12 plus what is area? 100 into 20 top section. This is 100 into 20. And what is the distance? Always y is the distance which is taken, the distance from the equal area axis, means this center to the this portion which is not equal area axis, y max, maximum distance. This is 105.6 minus this 20 by 2 which is 10. So that is the y distance here, that is 105.6 minus 10 whole square. Like that we have to take. Then next is this section, 20 into 1 BD cube by 12. So I will take here below line. I am writing continuously here. Second section will be here. I am writing 20 into 150 cube by 12. 20 into 150 cube by 12 plus what about its area? 20 into 150 only. And again what is y bar? Y bar again taken its distance by 2, means in this overall 150 distance by 2 which is 150 by 2, you will get 75 somewhere. So in this overall distance 150 by 2 means 755. In the 105.6 minus 75 means which you will get from this maximum distance, that is 105.6 minus 75 whole square. Like this, sorry, this is 75 only from the web part height, and again you can include this part also, top part also, that is plus 20 which is 95. So you are taken directly 95, means the center distance to the web to the top which is neglecting from the maximum distance 105.6 minus 95. And again this third section. For this third section you can take down from the bottom which is 84.4. Okay, I will show that one also. 150 into 20 cube by 12 BD cube by 12. Then area will be 150 into 20. And again this y bar. Y bar is the distance taken from the center to the maximum distance, that is 84.4 minus this 20 by 2 which is 10 whole square, means taken from the center to the top. So if you simplify all this value, directly you will get around 4101.35 to 10 to the power of 4 mm power 4. So this is I, and we know y max which is 105.6. So if you want a ZD value, take down I by y max, that is 14101.35 into 10 to the power of 4 by, you can take down directly all the values, by y max is 105.6. Then your value will be around 388.39 into 10 cube mm power cube only. So what about shape factor? We know shape factor will be equal to Zp by Zd. Already Zd value also obtained, that will be around 525 to 10 to the power of 3. So already we simplified. I am taking directly here, and Zd value will be equal to, which is 388.39 into 10 to the power of 3. If you simplify directly, the value will get around 1.352. So this is the shape factor for this particular data which is for unsymmetrical I section. So like that also you can find T section and various sections. Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.